Okay, so this is an example of a functional simultaneous equation type question, because we've been given information about two different companies and they've given us one bit of information drawn on a graph, and they're asking us to compare the other bit of information. Because there's a graph involved, then it's implying draw another graph, look at the two graphs and compare them in some way. So let's have a look. It's saying for the first bit, what is the cost of a unit of gas from company ABC? So if we bring the graph, then we can see that they've drawn us this graph, and we want to work out the cost per unit. Okay, so that's not euros, it's the number of units, because we made this question up. So we've got the number of units going along the bottom, and we've got the cost. Whenever you're doing this kind of question with graphs and that kind of thing per unit, it's per something, then it's shouting out, please calculate the gradient. So what we've got to remember about the gradient of a line is we choose two coordinates and we imagine a right angle triangle connecting those two coordinates. It doesn't matter which two coordinates we choose, because the gradient has to be the same anywhere along the line, but we tend to choose nice points on the graph. So for me, I'm going to choose 0, 0, and I'm going to choose this one here because I've got some nice whole numbers to work with. So there's my right angle triangle. What I need to then remember is the relationship for the gradient, and the gradient is equal to the change in the y coordinates divided by the change in the x coordinates. Now the change is really the difference between them. So what we're doing here is we had a y coordinate of 30 and a y coordinate of 0, so the difference between those means to take them away from each other, so 30 take away 0 is 30. And the change in the x coordinates, well, we had a change going from 20 down to 0, so 20 take away 0 is 20. So the gradient for this line, so for ABC, the gradient is equal to £30 divided by 20 units. So that equals £1.50 per unit. And that's what the question wanted. It wanted to know what was the cost per unit. So we've done costs divided by units to get that, and we've used the gradient of the line because that's how these graphs work, with the gradient being equal to the per one of something when you calculate it. So the gradient told us it was £1.50 per unit. The next part of the question tells us that there's another company, they want to try and nick the business from the ABC company. Like all markets, they'll put out prices and you've got to compare them to see whether one is better value than the other. Obviously modern technology now tends to tell you that through price comparison sites and things, but it's better if you work it out for yourself, and it's more fun. So we've got a fixed charge of £30 for this company, so we've got to realise what that means. It means when you've got no units, they're still going to charge you £30. It's a fixed charge for being part of that company. So that's where we put the fixed charge. And they're telling us that for every unit in this company it's going to cost you 75p onwards. So that means we want to work out some more costs. So if we think about the units used and the cost, then we saw for no units it was £30. Quite sensible to go across the graph a couple of times. So we've already got 1 point, so we just need 2 more. So we're going to use halfway across the graph in the end. It didn't really matter which we used, just as long as we've got 3 points to work with. So for 30 units, the question says that it costs 75p for each unit. Well, as the scale is in pounds, we'll work it out in pounds. So 30 times 0.75 is going to be 21. 30 times 0.75, so £21, and then we need 30 times 5, so £22.50. Okay, so we've got to add the fixed cost on, because obviously this is beyond the fixed cost, so it's going to be £52.50. And then for 60 units it's going to be 60 times 0.75, and 60 times 0.75 is 42 and 3, so that's £45, and we've got to add on the fixed cost again, remember, so altogether that'll be £75. So the cost of 60 units will be £75. So we've got our three coordinates. We've already plotted one of them for the fixed cost, so we've just got to plot the others. So 60, 75 is going to be there, and we can join that together. Because I know it's a straight line, I didn't really need to plot the other one. It's useful though to do it as a check. So 30, 52, 50, so 30, 52, yep, so that seems to work. And label, of course, really important. We're doing a description thing, so we need to label up. So this graph talks about that one being XYZ. So this is about cost, and they want you to compare the costs of buying the gas from each of these companies. So we can see as we go along that this company is dearer, it's costing more. So ABC is cheaper until we get to this point here. This is usually what happens with these kind of questions, is you find there's a point of intersection where one of the companies then becomes cheaper than the other one. So once we reach this point of 40 units, then we can see that XYZ will be cheaper. So when the question says compare the costs of buying, then we're going to say up to 40 units, company ABC is cheaper. After 40 units, it is cheaper to use company XYZ. Because it says which would you recommend, it's about making sure you've said something about up to 40 units, one company's cheaper, after 40 units another company's cheaper. So really it depends on how many units somebody uses, but at least by saying the number 40 they can be clear. If they use more than 40 units, then they know to go with XYZ. If they know that they use less than 40 units, they're better off staying with ABC. So that's an example of a functional question. Key points are to remember that fixed charges mentioned in questions means no units along the bottom, you're going to pay it whatever, so that's a fixed charge, and then you can work out what the graph will look like by working out the cost of the units and then adding on the fixed charge and so forth. So that's an example of a functional question involving two graphs and looking at the point of intersection.